Hey everyone, I hope you're having a great day. My name is Mark Skinner and I want to present to you my programming contest submission for the 2024 winter semester. At the outset, I want to mention that all the code in this project was written by me. For the contest, I thought it'd be cool to make some kind of solver. My favorite course last semester was engineering statics, so I decided to make an internal forces solver for beams. Here's a demo of the solver in action. The user first enters the length of the beam, and then it'll guide them to add forces, either distributed loads, point loads, or concentrated moments. When the user is done, they enter the word solve, and the program spits out the shear force diagram and the bending moment diagram, even with the max shear and the max bending moment. As I pondered this idea, I came up with some basic criteria that would guide my development process. For functional requirements, I wanted a way to allow the user to add various forces to a beam. I wanted the output to be graphs, displaying the bending moment and shear force diagrams of the beam. For the software criteria, I decided to limit myself to NumPy and Matplotlib, and have all the input and output be done through the Spider IDE. Also, having learned about linearity this semester, I decided to challenge myself to use as much linearity for the calculations as possible, while maintaining readability. Linearity in Python is when calculations are done on entire NumPy arrays rather than in loops. This made for some really interesting code. I started version 1 by implementing a user interface. I created a logic flow that would guide the user through the process of adding forces to the beam. I also created a data structure that would store all these forces in a usable way. In our statics class, we learned about how to do it using algebraic manipulation, but it was always different depending on the beam we were trying to solve, so I had to take a different approach. This is where I pushed away the keyboard and pulled out the paper. One thing I've learned about programming is that writing code is only a small fraction of the work. The majority of the time is spent understanding, refining, and abstracting the problem until you can see a plausible solution. Then you start coding. So I decided to cut the beam at every millimeter, or even thinner, and calculate the shear force at each cut for only one force at a time. It sounds like a lot, but for a computer it's light work. Using linearity for this part was really interesting. I continued to leverage the power of linearity to quickly sum all of the partial shear diagrams into the final shear diagram. In our design course, I learned that the bending moment diagram was simply the integration of the shear force diagram, so I had a new challenge. I know how to integrate some functions, but how do I integrate a function of thousands of discrete points? I remembered two things: the cum sum function from NumPy, and the trapezoidal rule for integration estimation we learned about in Math 100. Combining these tools and techniques, I managed to calculate a bending moment diagram. With this, I completed version 1. I showed it to some friends and they suggested visualizing the beam. I liked the suggestion, so I started on version 2, making some adjustments. After each force was added or removed, it would plot an arrow or two, or even a series of points to make a circle. For version 3, my final version, I decided to clean up my code and make it more readable. My uncle taught me that sometimes coding is like a messy workbench. You know where all the tools are because you recently used them, but if someone was to take your place, they'd be a little lost, so organization is super important. I also decided to refactor the code a little to allow it to be expandable and more easily modified. I arranged the functions in such a way that if I wanted to come back in the future and make some kind of graphical user interface, or maybe use its functionality in a different project, I wouldn't have to change much to get it producing results. So with that, I'd like to thank all my friends for the constructive feedback along the way, and I'd like to thank my course instructors for the techniques they've taught me and the opportunity to get a little creative in engineering. Thanks.